Assalamualaikum and very good day to all the reviewer. This video will be discussed about RLC resonant circuit by using MATLAB. This is the circuit of the RLC resonant that we are going to be used to find the transfer function Is. From the circuit, there are consists of three elements which are resistant, inductant and capacitance are connected in series with the single source. To get the Is, we are using KVL or Kirchhoff voltage law to analyze this circuit. We start with assign the current. The current flow in circuit is the clockwise direction. Based on that, the equation that we get is negative Vs plus Is multiply resistance plus j omega L plus 1 over j omega C, that it will be equal with 0. The Is that we get is Vs over R plus j omega L plus I over j omega C. To simplify the equation, we are represent the Z to become R plus j omega L plus 1 over j omega capacitance. Therefore, we get the formula Is equal Vs over Z. From the formula Z equal to square root R squared plus X squared, we substitute the value of X with the omega L minus 1 over omega C. Therefore, the last formula, we get Is equal to Vs over square root of R squared plus omega L minus 1 omega C. We move to the simulation by using the MATLAB. Firstly, we develop the code to get the waveform of transfer function Is versus frequency omega. This code consists of three main parts. First part, we set the parameter value. For Vm, we set 20 volt. For the capacitance, we set 500 millifarad, and for the resistance is 8 ohm, and the inductance is 2 Henry. For the second part is about command for transfer function hash and some of the formula to get the resonant frequency, quality factor and the bandwidth. For the last part is the command on to how to setting the graph. After that, we run the code and get the graph of transfer function Is versus frequency omega. After get the result, then we need to compare the result obtained by the MATLAB with the manual calculation. For the first calculation for proven, the first equation that we need proven is the resonant frequency. Based on the MATLAB, we get the value of resonant frequency is 1, and the manual calculation, same goes, we get 1 radian per second. Next equation is to find the bandwidth. To get the bandwidth, we need to find the omega 2 and omega 1, which is omega 1 is the lower half power frequency and the omega 2 is the upper half power frequency. So for the value of bandwidth, bandwidth is equal omega 2 minus omega 1. So the value that we get is 4 radian per second, which is same with the value on the MATLAB. For the last equation that we need to find out is quality factor. As the value we get is 0.25, same goes which in the MATLAB result Q1 and Q2, that is quality factor. By using the same code, we change the resistance value to increase the initial quality factor. So, we reduce the value of resistance from 8 to 6 ohm. Then, we proceed to run the code. Then, we compare the result obtained by MATLAB with manual calculation. We can see the value from the MATLAB for the omega node, as we know that the resonant frequency we get 1, and by using manual calculation we get 1 radian per second. So, we want to get the bandwidth value, we must get the omega 2 and omega 1, as we know that omega 1 is lower half power frequency and omega 2 is upper half power frequency. So after we get that, bandwidth is equal with omega 2 minus omega 1. The result we get is 3 radian per second, and we compare with the MATLAB value, we get band 1 and band 2, we get 3, is same with the equation. So the last equation we need to prove is quality factor, as we get the answer is 0.33, and we can see from the MATLAB same goes the answer 0.33. Next, for the last Q3, we reduce again the value of resistance from 6 to 4 ohm. Then we run the coding. So we get the waveform of the transfer function Is versus frequency. After we get the result, we compare the result obtained by MATLAB with manual calculation. So same goes as before this. We compare the resonant frequency with the stimulation. We get the omega node 1 radian per second. Same goes with the manual calculation. Then the second equation we need to prove is the bandwidth. We get 2 radian. Same goes with the simulating in the MATLAB. Then the last equation is quality factor. We get same answer is 0.500, same in the MATLAB simulation. Last one, we proceed with comparison of Q1, Q2 and Q3. First, we state the value of L and C are same for the 3 conditions. However, we use value of R in the different value for the each condition. For Q1, the value of R is 8 ohm. For Q2, we use 6 ohm. And the Q3, we use R 4 ohm. Based on the result, we notice that the lower value of the bandwidth will be produced with the greatest sensitivity. As we can see, the Q3 show the greatest selectivity, while Q2 is medium selectivity and Q1 is least selectivity. Last but not least, Q3 give the best selectivity. Now I will tell about function of series resonant circuit. The function of series resonant circuit, it is used for filtering and tuning purpose, as it does not allow unwanted oscillation that would otherwise cause signal distortion, noise, and damage to circuit to pass through it. And also, series resonant circuit used in radio and television tuning circuit, producing a very selective tuning circuit for the receiving of the different frequency channel.